Hello everyone, welcome to my channel. In this video, we will learn about what is meant by a blockchain and what are the advantages and drawbacks of the blockchain and how a blockchain works. So actually, people think of blockchain as a machine that generates bitcoins, but blockchain is not only used in the cryptocurrencies but also in the Internet of Things, government, health, finance, media, architecture, transport and supply chains. So what is the history of blockchain? Under the name Satoshi Nakamoto, a groundbreaking paper on peer-to-peer e-cash was published in 2008 under the title Bitcoin, a peer-to-peer electronic cash system. The concept of a chain of blocks was introduced and the true identity of Satoshi Nakamoto is unknown. He introduced Bitcoin in 2009 and up until 2011. He was an active member of the Bitcoin developer community. He subsequently turned over development of Bitcoin to its core developers and vanished. He has not communicated in any way since that time, and his presence and identity remain a mystery. The phrase chain of blocks evolved over time into the word blockchain, and blockchain technology now encompasses a wide range of potential applications across numerous industries. Now let's see what is meant by a blockchain. A blockchain is a chain of blocks that contain the information. So in short form, we can see that a blockchain is a chain of blocks. A blockchain is a peer-to-peer distributed ledger that is cryptographically secure, append-only, immutable. Immutable means it is very hard to change and updatable only via consensus or agreement among the peers. So here the word peer-to-peer means that there is no central controller in the network and all participants, that is the nodes, communicate directly with each other. This property enables the transactions to be conducted directly among peers without the involvement of a third party such as the bank. And here the word distributed ledger means when the technical description is broken down further, it becomes clear that the blockchain is a distributed ledger, which implies that each peer in the network has a copy of the entire ledger dispersed across the network. The next thing that we see here is that the ledger is cryptographically secure, which means that security services have been provided for this ledger using the cryptography to make it resistant to alteration and abuse. Non-repudiation, data integrity, and data origin authentication are some of these services. Another characteristics we come across in the blockchain is append only, which indicates that data can only be added to the blockchain in time sequential order. According to this feature, it is nearly impossible to change the data that has already been posted to the blockchain, making it practically unchangeable. To put it another way, blocks added to the blockchain cannot be modified, making it an immutable and tamper-proof record of transactions, and updatable only via consensus or agreement among the peers. So here the word consensus means its decentralized power is a result of the consensus. No centralized authority is in charge of maintaining the ledger in this case. Instead, any modification to the blockchain is verified against tight standards outlined by the protocol, and it is only published to the blockchain after agreement has been obtained among all network participants, including peers and nodes. There are several consensus facilitation algorithms that ensure everyone agrees on the final state of the data on the blockchain network and firmly agrees that it is true in order to reach the consensus. Now let's see what is inside a block in the blockchain. So time-stamped batches of previously valid transactions, the hash of the preceding block, and a hash, that is a digital fingerprint or unique identification, are all included in each block. Right? So in the each block we are having a data, previous data, and the hash. The prior block hash connects the blocks and prohibits any block from being changed or from being placed between two already existing blocks. The process makes the blockchain robust to tampering. So here the first block in the blockchain is called as the Genesis block. So it contains the data, and the previous data is 00 here because there is no previous node for this first block in the blockchain, and the hash value of the data. See, in the blockchain, for every block, so if you change even a single character, the entire hash value will change. So that will result in the changing of the hash values of the remaining connected nodes. So here each block includes the data, the hash of the preceding block, and its own hash. So if there is any little change in the contents of the block, the hash of that block will be affected, as well as the hash value of the nearby blocks will also be affected. So now let's see some of the features of the blockchain, that is consensus protocol, mining, distributed peer-to-peer network, hash cryptography, and immutable ledgers. See here, in the consensus protocol is a process that allows every peer in the blockchain network to agree on the distributed ledger's current state. Consensus algorithms accomplish dependability in the blockchain network and build confidence amongst the unidentified peers in a distributed computing setting. Blockchains contain a variety of consensus processes including multi-signature, practical Byzantine fault tolerance, and the proof of stake. Next, coming to the hash cryptography. So hash cryptography is nothing but a mathematical operation known as a hash function compresses one input numerical value into another. Although the hash function's output is always a defined length, its input can be of any length. Message digits or just hash values or terms used to describe values that a hash function returns. So next one is the mining process. So mining means adding new nodes to the blockchain. To the existing blockchain network, we are adding new nodes. So it is a process of adding new transactions to the distributed ledger of transactions already present in a blockchain. So here the mining consumes some power. So it requires a powerful CPU, more electricity, and more heat will be produced while performing the mining process. So in order to perform the mining process in the bitcoins, so each hash costs 25 bitcoins in the case of the Bitcoin mining. Next one is the peer-to-peer network. So peers or nodes are included in the decentralized networks of linked computer systems. So each computer or node may function as both a file server and a client. So normally internet works based on the principle of client-server computing. So here the client will request a page to the server and server will respond. But in the case of the peer-to-peer network, each node will act as both the file server and client. Hence, all nodes are equal in the decentralized system. And data interchange happens without the use of the central server. So peer-to-peer networks for file sharing include BitTorrents, uTorrents, RS Galaxy, FrostWire, and BitComet are some examples of the peer-to-peer network. A peer-to-peer network is a technology built on the idea of the decentralization. And one of the main features of the blockchain is it is immutable. So it is a immutable distributed ledger which is shared among all the nodes in the blockchain network. So here the immutable means no one can change the data in the node. So blockchain ledger's immutability is its capacity to stay unaltered, unchangeable, and irreversible. A cryptographic principle or a hash value is used to carry out each block of data such as facts or transaction details. So this is all about the features of the blockchain. So now let's see the advantages and drawbacks of the blockchain. So the main advantage is immutable. So it is supported by the blockchain and it makes hard to alter or change the previously recorded data in the nodes. As a result, the blockchain stops the data manipulation on the network. To maintain optimal application operation, the traditional database uses the CRUD model. So CRUD means create, read, update and delete. The CRUD model makes it simple to delete and replace the data. So such information is vulnerable to modification by the hackers. Okay, so which is not applicable in this model. And the next one is the transparency. Due to the decentralized nature of blockchain, any network user can validate any data entered into the blockchain. So that's why the public can have faith in the network. A typical database, on the other hand, is centralized and does not permit transparency. So next one is the censorship. As it is not under the control of a single entity, the blockchain technology is uncensored. So that means the network cannot be stopped by a single authority, including the governments. So it is a decentralized. So traditional databases have the centralized authorities that control network behavior and have the power to censor. For example, banks have the power to suspend user accounts. And the next one is the traceability. So blockchains establish an unchangeable audit record that makes it simple to trace the network changes. If there is any unauthorized access on the blockchain, so we can easily trace that thing. Since the typical database is neither transparent nor immutable, there is no assurance of the persistent trace. So blockchain is also having some of the drawbacks here. So we will see the drawbacks of the blockchain. That is speed and performance, high implementation cost and data modification. So blockchain technology performs more operations than a database. So hence it is very slower. It begins by performing signature verification. It involves the hash functions and cryptographically signing the transactions, a consensus protocol, and so each update of the node must be distributed to all the nodes. So all these things takes a lot of time compared to the database transactions. And here in the blockchain there is a redundancy where each node in the network must be essential to confirming and storing each transaction. So blockchain is having a high implementation cost. So blockchain is more expensive. So in order to integrate the blockchain into the workflow, organizations also need to plan and execute it properly. And the last one is the data modification. The data that has already been recorded using the blockchain technology cannot be easily changed. So to do so, all of the block's codes must be rewritten, which takes time and money. So it is difficult to fix a mistake or make any essential adjustments, which is a drawback of the data modification. So this is all about the blockchain. Thanks for watching my video.